Toby is an experienced energy professional and certified project manager with over 5 years of experience, who is passionate about solving problems, leveraging the power of teamwork and open communication. His area of expertise spans project management, petroleum geoscience, financial, data and business analysis. Over the years, he has led and executed projects within the finance and oil and gas industries. These projects range from the assessment of financial statements and records of companies to technical planning and evaluation of oil and gas data, culminating in the submission of recommendations in order to drive process efficiency, boost revenue, or save costs. Outside of work, he mentors fresh graduates and job seekers. He's also passionate about projects supporting child education. So let's welcome our guest speaker. We're excited to have you here, and we know that our participants are going to gain a lot from this session. So I'm going to be handing over the hosting rights to you so that you can share your screen, and then we would just go right to it. Thank you, everyone.
All right, thank you. Thank you very much for that introduction. Like she said, my name is Toby, and okay, I am host now, so I should be able to share my screen. Okay. Please confirm that you can see my screen now.
I can see your screen.
Okay, that's great. Okay, so let me just put it in slideshow, and then we kick off. Okay, please, I think some people are in the waiting room, so I want to admit. Okay. Good afternoon, everyone. I'm really excited to be here. I'm happy to be returning to present again with the NSI as North Star Initiative. It's always a pleasure when your team calls, and then I'm always happy to just do my bit in sharing whatever knowledge I can with the community. So for today, what we have lined up is what is titled here as Data Analysis 101. And the idea is hello? Okay. And please, can you mute your mic if you're not speaking? Yes. All right. So the idea here for today is we'll be looking at introducing the basic concepts of data and data analysis. We're going to look at the different forms of data and different ways that data can be used in the world today. And I think one other important thing to note is that it's a part of a two-part series, basically. So this first part will be introducing what data is and some simple concepts in what we call data analysis. And then the second part would now go a bit deeper, which will be on another session. I think next week we'll go a bit deeper into the idea of the different tools, software techniques that you can apply in data analysis. So let's just get into it. So this is my outline. I'll be starting with an introduction. Then I'll give a brief definition of what we call data and explain some concepts around data. Then I'll talk about how data has a close relationship with informed decision making. These days, people don't make decisions just based on instinct. You usually need to present facts to back back your decision. So we delve in a bit deep into that. From there, I'll talk about the applications of data, the different sectors that it can be applied in, the different spheres, different businesses, and different ways that it's applied. One interesting thing to note here is that a lot of us already deal with data in different forms, and if we are going to advance into dealing with much more complex data sets and making very informed decisions from data that we are availed, we will need to be conscious. You need to be conscious about the existence of data in its different forms. So that's what brings me to this next part that we're talking about data types and data forms. And before I then go into specifying on highlighting differences between structured and unstructured data. It's one aspect of the data space that there's a lot of there's a lot of work that is being done, and I just feel it's something that we should expand upon. And then I will now talk about the different sources for this structured and unstructured data before I give some general examples and conclude this session and take any questions that you may have. So that's the scope of this presentation or this session for today. So really in the last decade, especially, or in the last, let me say, 10 to 20 years, the idea of data science and its other sub-related disciplines have attracted a lot of attention. When I say some sub-disciplines, let me just give some examples of them. We have things like data analysis, data engineering, machine learning engineering, AI, and the likes. So these different aspects, one thing that they all have in common is the use of data, or the use of data to solve problems, or to deliver insights. So the last couple of years has seen these different aspects of these different subject matter areas attract a lot of attention, and companies have seen that there is a lot of value to be derived when we work with processed data, or when we work with data that we have available to us. So in the past, what we typically have is we would have like a management team that is run by people with vast years of experience, and then what the bulk of decisions that were being made was usually based on instincts. And while instincts and maybe experience is an invaluable, or you cannot dismiss the importance of this experience in these business decisions, as the years went on, people began to discover that some experienced executives there were some errors that were being made, or decisions that were being taken that were not being backed exactly by evidence. So this brought about this body of knowledge, or body of study, that ensured that maybe business decisions were being made with reference to previous data or available data. So this time you're not just going in blind to take a decision. You're looking at past occurrences. You're looking at your current current state of your business. You're now using that to make informed projections. For example, you cannot just say that you have, say, a small area of processing, of let's say a manufacturing plant that produces, let's say, 500 generators, and then you, as an executive, you can't just come up and then say that you're looking at producing a 1,000 or 2,000 or 5,000 units of generators without having the data to back that up. So, for example, in that kind of instance, you say you had a shipment of more equipment that would scale up your production to 1,000 or 2,000, then you can comfortably or confidently make that strong statement and say by next year, the facility will be looking at producing 2,000, 1,000 generators. So those are the different ways that people started to integrate current information into making their business decisions. So next year I said data. Hello.
Please, can you permit some people in? Can you admit some people in? Some people are on the waiting.
Okay. Okay. I see people are okay. Okay. All right. Okay, that's great. So here I now also spoke about data analysis, data analytics, engineering, and so on, having many applications in different industries. So you'd have, okay, sorry, let me just minimize this. Okay, so you have different applications in industries like energy. We have applications in banking and finance. You have it in engineering and so on. Wherever you have activities happening, and as a result of these activities, you're generating data or information, then you can apply concepts of data analysis, analytics, and engineering to improve the business proposition. So one thing that we would notice that is a central thing to all of these things that I've discussed is data. And that is what we are basically here to be introduced to, or to just demystify or talk about. Okay, let's see. So here, I want to talk about the concept of data. So one of the things that will immediately start being apparent to all of us is that data is all around us, and we interact with data. So I give a couple of examples here. So for example, you're just taking notes during a lecture. So your lecturer is speaking to you, and then you're recording notes. So what is happening is that you're capturing data in the form of sound, and then you're converting it to a written form. And then this data that you have in written form, you would eventually study, you eventually read, study this data you've taken down, you process it. Your lecturer on the other end is making use of his attendance list. So that's a collection of data. He has the names of students in text, and then with this data that he has on his own end, he prepares different tests and then your exams. And then from these exams, you write your exam, and then you get a grade basically, and then this grade is used to compute your, let's say, your grade point average or something like that. So you will see that even in this simple exchange, data has undergone different forms, and it has been transformed from the lecturer to you, to your notes, back to you, then back to an exam, then into grade or scores that is now converted to grades, and then now converted to a grade point average that is used to rank or grade students. So that's one way that data is just how we interact with data. Another one is just collecting customer information. So if you work in a store or in an office or whatnot, you typically maybe you need to reach out to a number of customers for sales and the like. So you'd be actively involved in the process of gathering that information. So the process of gathering this data is what we call data collection, and then you're recording it, and then from recording that data, you eventually make decisions on it. You can make calls based on it. You can decide to reach out to a certain number of people. You can decide to allocate this set of people with demographics. So, for example, you have someone on your team who is more youthful, young. You might want to say, okay, let this person talk to the young people, and while someone who is maybe more mature and experienced would be dealing with more aged and experienced customers. So those are some of the ways that we deal with data. So other ones that I mentioned here is that you can use it to record sales, you're logging your leave days, you're analyzing any form of results that you're getting, or if you're querying a database. This particular last point is something that we'll look at going into a bit deeper in our next session, and how we use different tools or languages like SQL, and how other tools like Python can help us efficiently get information, store information, and then retrieve information from databases. So now, what is data? I've defined data here as just the basic atom of decision making. If you notice, everything I've been speaking about so far, I have been linking data to eventual decision making. It is very important to note that while data can exist in isolation, it will not be useful to anyone or company if that bit of data is not used to inform an action or inform a decision. So if your data is just sitting somewhere, then that data is practically useless. So that's why I particularly defined it as the atom of decision making, especially is the atom of informed decision making. So it means that data basically is the smallest form or unit of information that an individual or company can use as a basis for reasoning, discussion, or calculation. Then something else to note is that the idea of data is very broad. So it will not be you will not be doing it justice if you just restrict it to maybe just what you have in a database, or just what you have stored in a sheet or a document. Or the data is very broad. It ranges from just abstract ideas to discrete or concrete measurements to statistics. And then another thing that you should know about data is that it can sometimes, in many cases, it can be measured, it can be collected, it can be reported, analyzed, and used to create visualizations. And these visualizations can aid decision making. One key thing to kind of note here is that a challenging aspect of dealing with data or using data to inform decisions is the process of data collection. So data collection is a very sorry, is a very elaborate and can be a painstaking and complex process that if you don't carefully do it, it would affect subsequent work that you are trying to achieve on your project. So here I just want to talk about data and decision making. So for example, if I get the scenario here, like with limited funds available. So I'm going to kind of throw this question a bit to the house and just see if I can get some sort of feedback. So let's look at the first one. With limited funds available, should the management of a company invest in the purchase of an asset, or should they upskill their staff in the use of a modern tool or technology? So I would just like to take like maybe 3 perspectives to this first one. I don't know if anyone can just share. So just this first one, with limited funds available, should the management of a company invest in purchasing an asset that will probably increase production, or should they upskill their staff in the use of modern tools and methodologies? Let's take them maybe 2 to 3.
Okay. Can I say something?
Yes, Favor, you can go ahead.
Okay. In my opinion, based on data, it can be concluded that most staffs, when unskilled, eventually leave the company. So the cost of upskilling the company, I mean the staff, may no longer be worth it, because eventually, based on statistics, these staffs end up leaving the company. So it may be better to get a new asset. So
Okay, well
that's my
said,
perspective.
Favor. All right, thank you, Favor. Any other perspective, even if it's contrasting, I would be willing to let's just share our perspectives.
Please, can you let some people in? I have information that some people are still in the waiting room.
Okay, I've been seeing prompts and I've been letting people in as they come up here. So once they come up, I will just
Thank you very much.
Yes, yes. So I don't know, does anyone want to just maybe if you want, you can also share it in the chat. Do you have any submissions in the chat room? Okay, that's fine.
I can't see any for now.
Okay. Okay. So what Favor has said is actually also it's correct, but then there's one thing to note is that you need data to inform all of these decisions. So, for example, if in this instance you decide to purchase an asset, and that asset actually requires a particular level of expertise to operate or use, then you would agree with me that it might be also important that the company also looks at upskilling their staff, because some costs will also come with purchasing and installing and learning how to use that said asset. So the point I want to focus on here is that when companies or when people want to make most of these decisions, it is very important that you put into consideration all factors that contribute to each decision. So, for example, in this asset, you're looking at what is the cost, what is the use, what is the skill level required to use it, and in the other side, you're thinking about okay, what will be the return on investment? How long would the typical staff? What is the average turnover in the company? So how long would they typically stay before before your staff maybe they move on to other companies or other roles? So those are the things that you need to consider. So there's no particular wrong or right way to look at this. The appropriate way of evaluating this is just for you to know that you are making this decision with facts backing up what you're deciding to do. So this other one, I think I will give a bit of perspective on it. So here I just said, if you're considering 2 drilling projects, so I'm giving this perspective because I function more in the energy industry. So considering 2 drilling projects based on reservoir size, your reservoir is where you get your oil or your gas from, and so you're considering 2 drilling projects, and based on your reservoir size and your hydrocarbon type, which is maybe oil or gas, and immediate company needs, you don't know whether you're thinking whether you should drill maybe this one or this oil well or this gas well. So at this point in time, like what I said earlier, you need to consider the different things that contribute to your company's success. So, for example, you're looking at what size of reservoir do I have? Am I talking about what amount of maybe energy can I get from this particular reserve? How much can I make from these different projects? Will I make enough money to pay off the investment that I have made on this project? So when you look at things like that and consider these individual factors, the decision that you would want to make as a company starts becoming clearer to you. Yeah, so that's about that aspect. So next, I want to just talk about the applications of data. So I'm giving different perspectives here. The first one is, so an accountant will just need to record entries for the purchase of an asset. So remember the last example we talked about buying an asset. So in the industry or in the businesses today, your work does not just end where you buy assets or you just train staff. There is an important need for you to record those activities or for you to record those transactions for maybe regulatory purposes or for reporting purposes. So if you're maybe seeking investment, people want to know how your company has been doing in terms of its purchases, its expenses, let's say its revenue, how much it's been making, or its profits, how much it's making after you remove all of the associated costs with the production. So here, an accountant will just need to record entries for an asset, and subsequently is recording those entries for the assets in an asset account, and at the same time, you must, as time goes by, you must also recognize something you call depreciation, because your assets as it's being used is it depreciates from the value reduces from one year to the other as long as it's being used. So there is an important need for you to record or to recognize that depreciation in quotes. The next, as an external auditor, you may be on the other side. So you might be the one now looking at the records of the company, and then you are now trying to ensure that these recordings that this company has made, you're trying to make sure that they are fair and they are a true and representative statement of the activities of the company in quotes. So you're looking at it and making sure that things are not overstated, understated. But overstated and understated, I mean, I hope you are not exaggerating the cost or the value of the assets that you have in your balance sheet, on your books of record, or that you're not underestimating your expenses so that your profits would be larger. So those are some of the ways this data is applied. So we look at financial data, accounting data in this context, and then from it you make you perform different analyses, you do different tests, and then you come up with results, which in this case might be statements or audited financial statements. Next, in energy exploration, data usually has to be skillfully collected. So I mentioned something in my second example the other time. They were considering a drilling project. So in the energy business, especially in oil and gas production, it's one of the challenges is even finding the resources to extract. So you need to put together different data from different sources, like you look at things like seismic, look at things like well log data, you look at things like magnetic surveys and gravity surveys and things like that. And then from all this data, you integrate it, and then you are able to pinpoint locations where you have economic accumulations of these oil and gas resources. And then from these different data sets, in fact, like in the past, like a failure to carefully integrate these different sources has led to failed projects where you now have people drilling dry holes or dry wells, and then this leads to loss, or this costs the company a lot and causes them losses in terms of revenue. So here I just said having this right, having and integrating this the different or the right data can be the key differentiator between a successful campaign and just another failed project. And I just gave an example here that it might just be seismic data, it might just be well log data and so on. But it is very key that you, one, source for your data, two, you make sure your data is usable, so you're cleaning it, you're interpreting it, and then you're using the results of the interpreted data to inform decisions that your company would have to make. So next, I want to talk about the data types and forms. So when we talk about this, the truth is that data types and forms can be looked at from a multitude of perspectives, from so many perspectives. But I've just decided to focus on three perspectives. being one qualitative versus quantitative data. And what do we say? What would we say qualitative data? So qualitative data is basically data that is qualitative, so it's explainable. It's made up of maybe words. You don't necessarily measure it. While quantitative data is data that you can count, you can measure it, you can attribute numbers to it. Qualitative data is something is so if, for example, if I went to a football match and then I was to document qualitative versus quantitative data, I would say, so the qualitative data aspect would be like, oh, the field was very large, the field was green, I saw goal posts, and then there were many people, at the footballing event. That's qualitative data. And if you look at it, this person has explained himself, explained the situation. You can sort of make sense of what is happening. But one key thing is missing from this thing, and it's numbers, figures. So look at another perspective. This person is now explaining from quantitative angle. He's saying that there are 2 goalposts. From the records that I saw, there are about 2,000 people in attendance. There are 20 people maybe currently playing on the field. So number of people have gotten yellow cards or red cards at this point in time. So at this point, we're now attributing numbers to what you described earlier. So it's also very similar to this next one that we have discrete versus continuous analog data. So but the key thing to note is that discrete is usually like something like, so what you'd consider discrete data is what you'd call data that you can count digitally. So it's made up of zeros, ones. So you're counting in discrete whole number forms. While analog data is made up of measurements. So one easy way I used to maybe differentiate these two main types is that, for example, discrete data is, say, maybe your digital watch or your digital weighing scale, while analog data for the same thing is maybe your normal analog watch that just has hands pointing to the hour and the minutes and seconds parts of your watch, or a weighing scale that just has an indicator that moves from one point to the other. So while one is in discrete form, giving you 1.0 points, giving you exact measurement, the other one is like it's between a range of measurements. So the third one that I want to talk about here is basically structured versus unstructured data, and this aspect is usually very important in the context of data and data analysis and that whole industry. So I'll just go a bit deeper into it in the next slide. So what would we call structured data? So structured data in just simple definition is data that is organized into tables. So they're organized into what we call rows and columns. So usually you will have this data being organized into what you call fields and then rows. So you would have an attribute, say, for example, you're taking weight of students. So the structured data for this is that you have student name, and then in the next field, you have student weights. So you have different weights for different students. That is structured data. And then next thing I said here is that structured data can exist in standalone tables, or it can exist in a sets of tables, really. So you might have a different set of tables that are now related to one another by one or more fields. And this right here, that what I have described is what underpins the concept of a database, especially a relational database, where you have different standalone tables or records, and these records they bear relationships with themselves. So, for example, I have this table that just quickly collects data on the students' biodata, so their names, their address, and co. And then I have another table that takes information on their their scores in a subject. So in this database, we have student biodata, we also have students grading and scores. And then that's what makes up the idea of the database. So under here, I just give some examples of structured data. So you have sales records and databases. This typically what it would look like. So a pictorial form of what your database is, what you're seeing on the left, where you see different tables being related to themselves with different relationships. And then a typical table within that database will look like what we have right here on the left, where we have like an ID field that basically defines what we have in each record in the database. And then you now have things like fields, like what we have in first name, last name. So fields collect specific information of specific traits, while your record is a collection of all the traits relating to a unique candidate, value, person, or object. Okay, let's see. Admit all. Okay. So next, I want to talk about unstructured data. So unstructured data is practically every other thing that you have aside from this structured data. It takes on different forms. It has a broad it has a broad it has a very broad range of form that it takes. So, like I said, the name already suggests that you don't have your data organized into a perceivable structure. So usually the data is in raw formats, and usually they are not structured into tables, rows, and columns. So, for example, we have things like audio recordings, like sounds, and we have things like images, pictures, satellite images, like what I have on the right here. It's just a satellite imagery of a location, and really it's unstructured data, because this, as it is like this, is not necessarily data that is into rows and columns. And while there are ways that you can convert unstructured data into structured data, for example, when you have like a map data like this, there are times when you can now attribute different properties to different geographical locations. So you now have things like your X coordinates, your Y coordinates, your Z coordinates, your X being maybe something like your eastings or longitude, and then your Y being your latitude, and then you now also have Z, which is like maybe elevation data for that particular area. So from what I just explained now, you see that even, for example, pictures can then be converted from an unstructured format per se to a structured format that can be easily accessed or analyzed in what we would now call conventional databases. And this is a whole field on its own, where people that we call GIS, that's Geographic Information System Scientists, where they specify, where they specialize, they deal with just bulk of this analog, unstructured and structured data relating to geographic locations, and they try to make sense of it and carry out plans and different activities and other things related to that. So next, I just wanted to make a key distinction between structured and unstructured data. So on the left, one of the very obvious things that you please see that is that structured data or unstructured data is far more than what we have as structured data. And it is usually for this reason that, in fact, the data industry has been booming, because a lot of people want to make sense of data that doesn't have perceivable form. So there are pictures, there are lights, there are things like that. But these companies want to start making sense of these things. So we have a lot of unstructured data out there. And here it's like a ratio of 80% to 20%. So you have just your structured data making up just 20% of your entire data pool, while 80% is what we call the unstructured data. So to the right here, we have some key distinctions between structured data and unstructured data. So for one, structured data can be displayed into rows and columns. while unstructured data are typically not. They are stored as, your structured data are typically stored as numbers, dates, strings, but unstructured data takes on different forms: images, audio, videos, word processing files, emails, and so on. Another one is that what I mentioned earlier is just about 20% of enterprise data, like all the data that you have available to you. While unstructured data makes up 80%. So you see that when you work in like the data space, you have a lot of work to do, because this 80% is just sitting there and waiting for you to make sense out of it for your stakeholders or management of your company. Next, generally, structured data takes far less space than your unstructured data. Just think about it. Look at your average, maybe table, your average size of a database or a table or a sheet, and then compare it to, say, maybe a 1 hour video, 1 hour video recording, and then you see, oh yeah, and by the time you compare the amount of information you can extract from something, you see that the structured data, even when it stores less information, it's usually easier to work with than which is what brings me to the last point. It's easier to work with, it's easier to manage than unstructured data. So finally here, to just conclude, one thing is apparent in the way we do things, is that most of the decisions that we make, especially in this in recent time, is that data interacts with our life, and most of the decisions we make is influenced or impacted one way or the other by data. Another key thing to take away from this session is that data has so many forms, and it is in the value that we can get from extracting insight from these different forms that the different opportunities in the data space comes about. And then then the final point here to just conclude is that before we can start taking advantage of data and maybe start up a career in data, and a very important thing is that we need to first be conscious about how data interacts with different aspects of our lives, so that we can efficiently, effectively exploit its applications or advantages. Thank you very much for listening. I would be willing to take on questions from you. And I want to also just know that there's a second part to this where we now talk about using some specific tools to carry out data analysis. So I'll be questions, comments, and let's just discuss next 10-15 minutes.
Thank you so much, Toby, for that insightful presentation. I'm sure every one of our participants has learned a thing or two. So you now have the floor, everyone. Ask your questions, share your comments, and I'm sure Toby will be happy
to go to the chat room. So if there are questions in the chat room, please, you could just read them to me. Thank you.
Sure, that's fine. So guys, let's have your questions and comments. Feel free to unmute your mic and speak, or if you rather type them in the chat box, that's fine too.
So that means everyone is on the same page with this presentation. Everyone understands. There are no questions. Nothing you're looking forward to, or your key takeaways from the presentation.
Okay, I would like to ask a question.
Okay, go ahead. Go ahead, sir. Thank you.
I'm quite curious. After obtaining data, you made mention of how data is being obtained. Now, is there a particular methodology to extract information from data? Because you made mention of something that data is useless, it does not provide information that we can use to make decisions. So is there a methodology, particular way to extract information from data? That's my question.
Okay, thank you. Let me just put this out there. So usually when you obtain your data, there's something called extraction, transformation, and loading. So the idea is basically so that your data will not be useless. One, you have extracted it. The next thing is that you're going to transform this, and then you're going to load it for different use. So your question is that, is there a methodology to this process? So there is no one size fits all for the workflow of making sense out of your data. But and also another thing to note is that different tools have different let's say transformation techniques before you can make sense of your data. So for example, say so for example, you look at the website and then you see comments or related to a particular subject. So you want to extract some of these comments for analysis. So say you write a script on Python, you've pulled out this, you scrape that page or that site for, let's say, the comments, the subject that the comment is talking about. And then the next thing you want to do, the process of you stripping that data from the website is the process of the extraction or the collection. Then next, you now want to transform that data. So you might need to extract certain things from what you have already extracted from the site. So, or you might need to process it. You might need to run some computations on it. So, if, for example, I've gotten data relating to say revenue or sales figures and things like that, I might not need to go a step further to calculate profits or the number of hours that the machines are working. So these different approaches are transformative, like you are transforming the data that you have collected into another form that can now be used. So you've collected revenue data, collected time from your machines. Oh, I've worked these hours. But now you're not transforming it into, okay, revenue minus cost is sales. So you're transforming it into another form that is now more useful by yourself and the company. So to answer your question, there is no one locked methodology that you use to transform your data to a usable means. But the key idea is you're extracting your data, you're applying different processes to maybe strip or transform it, and then you are now making sense of the data and then loading it. I don't know if that answers your question.
Yeah, you answered the question. I just want to add together. Are you going to teach us how to the various methodologies, or maybe at least one in the next session, or it's not part of the scope?
Okay, yeah. So that is we'll go a bit into that next week. And the truth is, while you cannot get all of the value as to how maybe to use the particular tool or technique or procedure, I would do my best to sort of introduce you to the said tool or technique, and so that you can maybe just take off from there and then begin to develop yourself in that regard. So yes, we'll be looking at maybe learning one or two things about one or two tools, softwares, or techniques. Thank you.
Thank you very much. There are some questions in the chat.
Okay, if you could read it. Really read out, I don't know. NSI?
Okay. Do you want to go ahead, Favor, or should I?
No, please go ahead.
Okay, that's fine. So from Tobiloba, we have a comment saying, thanks for the introductory presentation. I really look forward to the next session. A big thank you to North Star Initiative. So thank you for attending this session too. We are glad you enjoyed the presentation and learned one or two things. So from Francis Yaji, we have, sometimes the data gotten from some of the departments are not sufficient to make use of it. In such case, what will one do before analysis of it? Thanks. So should I take all the questions or one by one?
One by one. I'll just take them. So thank you. Is that Francis, right?
Yes, Francis.
Yeah. Okay. Yeah. So what you have described is a common issue that data analysts and data analysts face in the workplace. So the truth is, an important part of making sense of your data is that it has to be for an eventual there has to be an eventual end goal. So if, for example, the data that you have collected cannot help you in maybe answering your set questions, then it means that the process of data collection is not complete. So it probably means you probably need to talk to maybe other stakeholders that are involved. So you might need to talk to other departments that might be custodians of the data that you are looking for, or you might need to escalate to maybe management. Maybe something that the departments do not have. You might need to escalate to much more senior people who might be able to now help you source for such data. Then another thing for us to note is that maybe as analysts, people that make sense out of data, you will not always have all of the data that you need to make the best kind of analysis that you have. Where your core data analysis skills now comes into play is that you must be able to make sense of what you have. So I have this set of data, and from this set of data, this is as much insight that I can give you. I will not talk about any other thing that my data is not speaking about, because the data doesn't support me talking about that. But as far as this maybe presentation goes, this and this is what I can derive from it. So it is always good to know that you will not always have all of the data that you need to carry out maybe the best sort of, or the ideal sort of work that you want to do. But as a thriving data analyst, you would want to try and maximize the resources that you have with you in order to make as much sense as possible out of the data you receive from different departments. Yes, so you can, another question, please.
Okay, thank you for that response. I can see that Jeff Roland's hand is up, so I'll let you ask your question before I proceed to read the question in the chat box. So do you want to unmute your mic, or is that hand raised a mistake?
Hello. The question during the course of this presentation, you talked about how data interacts with the different aspects of our lives. And then also during the course of the presentation, I noticed the data space. That's the 80% data space that you talked about. So I would like to know the opportunities that lies within, to enable one who is possibly a data analyst to maximize the advantages that comes with data analysis.
Okay, that's fine. So the first aspect where I talked about how data interacts with our lives at different points, it's so for example, every basic thing that you do. So for example, if you're going to feed, you're going to go and eat, you want to eat now, you have to leave where you are, or you need to go and prepare the meal or something like that. So at that point in time, you might not necessarily see it as maybe data is being transacted or anything, but so now imagine that, say, I'm an analyst that is supposed to be monitoring maybe people's feeding and shopping habits. Then I will now be particularly interested in, what times do most people get up to maybe have breakfast, lunch, or dinner? What kinds of food do people from a particular, maybe from Lagos, what food do most people eat in the morning, or do they order for in the morning from a shopping or from an e-mall and other things like that? So you begin to see that there are opportunities. So things that are just like maybe your habits and all. This is what companies like Amazon are mining. So they're looking at maybe like your shopping habits, your purchase history, things that you're searching for, and they're using it to recommend things that you are likely to buy or likely to purchase. So these are some of the ways that some of these companies have been able to identify opportunities that were just lying there before. Before, people were just buying food in isolation, buying products in isolation. But at some point in time, people said, it looks like certain people buy these products around this time. It looks like certain people from this, maybe from this field, they tend to buy this product. So maybe it will make more sense to market these products to maybe to engineers than to market it to accountants. So those are some of the ways that people started using data to inform or to extract opportunities that brought about business value. I hope that answered the question.
Okay. Thank you very much. That was very, very expository. There is a follow-up to that, please.
Yes.
Okay. The topic of this particular presentation encapsulated the data analysis using Power BI, Excel, and PowerPoint. So I don't know if there are other phases of this particular presentation that will cover.
Okay. So I mentioned it earlier that it's a two-part series. So the second part, which will be next week, would now be the part that focuses more on data analysis and some data analysis tools. So this first part is more like an introduction. Yeah, just to awaken our consciousness, and then the next one is into the analysis proper. Thanks.
Deeply appreciate. Thank you.
Okay, so I would read out, I believe that's the last question we have on the chat. And this is from Miracle. It says, he or she says, I have two questions. One, must I be very good in Python before I can start learning data analysis? And two, you said in data analysis, we need to get data to analyze before we make decisions. But how do we know the questions to ask ourselves to get the data that will inform the decision making? So I can go over it again, or is that fine?
Okay, yeah, I'm fine. So yeah, so that's a very good question. So in order to be a good or a great data analyst, you don't have to be an expert in Python. If anything, I would say that the most important maybe skill to have is to just have that inquisitive mind. So you have a mind that's always asking questions and wanting to solve problems. So on that note, I want to just talk about like a big part of it. In fact, it's common discourse in like data space that most of the flamboyant things that is learned during the course of learning to be a data analyst, data engineer, and all of that, it's applied in maybe just 20% of the work. Most of the bulk of your work would be asking questions as to how can this data make sense? How do I get out this data? What kind of data do I need for this particular analysis? And that brings me to your second question. And which my answer would be that you just need to always have to have that mind that always seeks to identify business problems or personal problems. So if you can identify business or personal problems, you can begin to start thinking of ways that, or you can begin to start thinking of data that supports you answering or solving such problems. So like an example I gave earlier about basically the shopping business. People wanted to maybe maximize their sales and all of that. And then you began to see that when I market certain products to certain people, my conversion rate is higher than when I just advertise these goods to everyone. So in summary, when you have that mind that is always looking at, oh, what is the problem in this space? What is the problem that these people are facing? After you identify the problem, then you begin to start thinking, what sort of data is related or closely associated with that data? From there, you can now start collecting and start piecing the different data sources together and start gathering your data before you can now perform the analysis and make sense out of it. I hope that answered that question or those questions.
I'm sure it does. Thank you so much once again. We are about 1 minute beyond our designated time. So we have, okay, these are comments basically appreciating our facilitator. So we have, thanks for this lecture. I really appreciate, God bless you. Looking forward to the next class from Francis. Thanks for the answer to my questions. You made it really clear. And thanks for this session from Miracle. So thank you so much, everyone, for taking our time to join this session. And of course, a very big thank you to our presenter once again. Toby is a member of the NSI family, so he's always around. You can always reach out for questions and clarifications on anything that he has presented. And we definitely look forward to having you on the 24th of September. So thank you once again, and everyone do have a great weekend.
All right, thank you very much for having me. It's been
Thank you very much.
pleasure.
Thank you, sir.
Sure, we'll share the recording fee. Thank you, everyone. Thank you.
Thank you. God bless you.
All right, thank you.
Bye. Take care.